All right, guys, let's put that away for now. So we got.
Wait, we're not doing this.
So you have that. We're finishing the note sheet because I want to do one or two more. We only got one Descartes' rule of signs done. So I want to have y'all see two more so we can kind of see how this works. And then you'll have the rest of the time to work on the makeup assignments. And when we come back Monday, and we get back here on Monday, we're going to go over the review. If we do finish the review on Monday, your test is Tuesday, Wednesday. If we don't, your test is going to be Wednesday, Thursday. Now, Descartes' rule of signs says that the possible number of positive zeros is equal to the number of sign changes of the original function. So if we go through here and count the sign changes from term to term, it will tell us how many positive zeros we will have. If there are any missing terms, we don't fill them in. If they're missing, they're not there. We don't care about it for Descartes' rule of signs. For long division, synthetic division, we need to fill them back in as zeros or 0 times that term. Now, as we look at this here, from our first term to our second term, it goes from positive to negative. Then we go from negative to negative, so there is no sign change. Negative to positive would be our second. Positive to positive, there is no change. Positive, positive, no change. And lastly, positive to negative would give us 3 sign changes. So there's going to be 3 positive zeros or less than it by an even amount. So we can subtract 2, giving us 1. So it's either 3 or 1 positive zeros. Now, finding the negative zeros, we take f of negative x. F of negative x. Now, we went through this process a little more in depth yesterday, where we plugged negative x into every x and then did the simplification. But the biggest thing we got from it is if the exponent is even, the sign stays the same. If the exponent is odd, we change the sign for this f of negative x. Now, our first one, x to the 6th, since the exponent is even, the sign's going to stay the same. It's going to stay positive. Our next one is 5x to the 5th. Because the exponent is odd, we have to change the sign from negative to positive. Our term after that is 3x to the 4th. Now, since the x is to an even power to a power of 4, the sign stays the same. Since it was negative, it's going to stay negative. Our next term is 3x cubed. Since the exponent is odd, we have to change the sign from positive to negative. Our term after that is 10x squared. Since the variable's exponent is even, the sign is going to stay the same. It's going to stay plus. Our next term is x, or really it's x to the first power. Power is odd, so we'd have to change the sign from positive to negative. And the last number we have, our constant term, is 9, and because there is no variable attached to it, the sign does not change. Now at this point here, we go back and count the sign changes. For our first 2 terms, we're going from positive to positive. There is no change. Then we go from positive, negative for 1. Negative to negative is no change. Negative to positive gives us 2. Positive to negative is 3. And negative we don't count. So our negatives, we'd have at most 3 or less than it by an even amount, giving us 1. Now the first one we did in this one here, we did get 3 positives and 3 negatives. It doesn't have to work that way, it just worked that way. Count the number of sign changes and less than it by an even amount. Positive, negative, complex. Really what this table is giving us and arranging every possible combination of our positive solution numbers, 3 and 1, with the possible number of negative solutions, 3 and 1. and we fill in the complex for the missing solutions that we should have. So across each row of this here, we should have a total of 6. So for possible positive negatives, because they could both be 3, and if I have 3 positive and 3 negative, that is 6 solutions, which means I'm not missing any out of the total, so I should have 0 complex. The next arrangement we should have is 3 positives and 1 negative, giving us a total of 4. I need it to be 6, so we're missing 2 complex. The next option that we have is 1 positive and 3 negative, which again is 4, telling me I'm missing 2. And our last arrangement is 1 positive, 1 negative, telling me I'm missing 4 solutions. So we get 1 positive, 1 negative, and 4 complex. One thing that's interesting to note is that the number of complex solutions will always be an even number or 0, because they have to come in pairs. If A plus BI is a solution, A minus BI is a solution. They will always come in pairs of 2. So the number of complex has to be even, no matter what the setup is. Questions on this here? This is the other one we're going to look at. F of x equals x cubed plus 9x minus 25. Now for our positives, we're just going to count the sign changes. Even though x squared is not listed, that is fine. X cubed to x, we're going from positive to positive. There is no sign change. From x to our constant term, it's going from positive to negative, so there is 1. The most sign changes that we have for the positive is 1, which means we have 1 positive 0, or less than it by an even amount. So if we try to subtract 2 from 1, we get negative, so there can't. 1 is the only option. Now for our negatives, we have to plug negative x in for every x. Or realistically, when we're doing this, if the exponent's odd, we change the sign. If the exponent's even, it stays the same. So x to the third, that third power is odd, so it's going to have to change from positive to negative. Our 9x, it's x to the first power, so that power is odd, so it has to change from positive to negative. Negative 25 doesn't change because it does not have a variable. And since we're finished with plugging that in, we can count the sign changes. And since all 3 terms are negative, there is no change. Because we're going negative to negative, then the negative to negative, telling me that the number of negatives solutions is 0. Now this makes setting the table up quite nice, because the most positives I can have is 1. The most negatives I can have is 0. Now the total number of solutions has to be what? 3. If I have 1 positive and 0 negatives, how many complex should I have? 2. Because even though it says an even number less, I can't have 2 less than 0. I can't have 2 less than 1. This is the only arrangement of solutions we can have for this problem. We can only have 1 positive and 2 complex. Doesn't work any other way. Questions on this here? And really, that's it. That's all we have to do for these problems here. Now you have the rest of the class time to work on your missing assignments. And we will start going over the review sheet on